In this chapter, we're going to talk about testing in the clean architecture because tests are an essential component to designing a production-ready application. The first question you want to answer is what should you be testing in the first place? And the answer to that is that you should focus your testing efforts on the application core. The application core consists of the application and the domain layers. The application layer contains your use cases and the domain layer encapsulates the business logic. I'm going to show you how to write a few different kinds of tests because they all serve a specific purpose and come with their own advantages. I'll show you how to write unit tests for the domain and the application layer. Then I'll show you how to write integration tests, and the variation I'm going to use is also known as subcutaneous testing. We'll also focus on functional testing. It's also called end-to-end testing. And lastly, I'm going to show you how to write architecture tests to enforce your software architecture and design rules using automated tests. We have a lot of tests to write, so let's see how we are going to implement them. We are going to start our discussion about testing in the clean architecture from the domain layer by writing some unit tests. I already prepared a unit testing project which uses XUnit as the testing library, and the project is called Bookify Domain Unit Tests. This is also a naming convention that I like to follow, where the test projects contain the name of the library that I'm testing and also the type of test that I will be writing. So in this case, I'm testing the Bookify Domain project and I will be writing unit tests. Hence, the testing project is called Bookify Domain Unit Tests. Let's also add a project reference to the Bookify Domain project from the unit testing project, and now I'm going to discuss what are some good candidates for unit testing in the domain layer. What I will typically focus on is the domain entities or the aggregate roots. A good example of this is the user entity. For example, we could unit test the create method and verify that it is properly creating the user, raising the domain event, adding the role, and so on. One more entity that could be interesting to test is the booking entity because it contains some interesting logic in the reserve method, and it also has a bunch of other methods for confirming, rejecting, completing, or canceling the booking. And lastly, you should also be unit testing your domain services. Here I have the pricing service that takes in an apartment and a date range representing the period, and then the pricing service will calculate what are the pricing details for these parameters. I'm going to start from the user entity, and I want to cover my create method with a few unit tests testing this behavior. The convention I like to follow is to use the same folder structure in my unit test projects. So I'm going to create a users folder, and inside of it I'm going to create my testing class. So let me add a new class that I will call user tests. This class will hold my test cases for the user create method, and how I'm going to write a test is by decorating a method with the fact attribute. This is a convention from XUnit, and it might be different depending on which testing library you want to use. So I'll make this method void, and then we need to give our unit test a name. The convention that I like to follow is to first describe what is the system under test, or in other words, what is the logical component that I'm testing. There are two ways you can look at it, that I'm either testing the user entity or the create method. I personally prefer focusing on the methods because it makes it more obvious for me what I am testing. So for example, my test would be called create, and then I will describe what should happen. So for example, create should set the property values on the user, and if I have a specific condition, I'm going to write that as when or if and describe what is the condition that I'm testing in that scenario. Because this is a simple unit test, this is everything I need. And then inside of the unit test, I like to follow the arrange, act, and assert format, where I split my test into three parts. The arrange step, where I will prepare any objects or mocks that I need to run my test. In the act step, I'm going to execute the actual test. And then in the assert step, I'm going to verify that I got the expected behavior. If I go back to the user create method, you will see it has three arguments: the first name, the last name, and the email of this user. So what I can do, instead of repeating my test setup for all of my tests, is to create a small helper class. For example, I can call it user data, and it's going to contain some static values with the data that I will be using inside of my tests. Let's move the user data into its own file, and inside of it I just defined three static fields for the first name, last name, and the email. Now if I go back to my test, we no longer need the arrange step because I already prepared the values for the first name, last name, and email inside of the user data class. So I can jump straight into the act step where I'm going to create a variable to hold my user, and we can call the user create method. Now I can use my user data class to pass in the first name, the last name, and the email to this method. And then we need to write our assert step where we are going to verify that the user's property values are correctly set. Now you could use the assert syntax that is built in to write your assertions. For example, I would write assert equal and then specify what are the expected and the actual values. However, I prefer a more functional approach, and for that I'm going to install an additional NuGet package. So let's browse for the Fluent Assertions package, and I'm going to install the latest version. Fluent Assertions allows me to write my assertion steps in a more functional way. So for example, I can say user first name should, and this is an extension method from Fluent Assertions, and then I can say should be, and I can specify user data first name. Let's repeat this for the last name and the email, and then we're going to run our unit test and verify that we are getting the expected behavior. Let's open up the Test Explorer, and I'm going to run the single test that I have so far, which verifies that we create the user and correctly set the user's properties. And you can see that our unit test is passing. Let's write one more test targeting the user create method that's going to verify some behavior. So I'll say create should raise user created domain event, and then let's go ahead and write our test. I can copy the act step, and I'm also going to use the assert comment because the start of my test is similar, but now I need to assert that this method correctly raised my domain event. If we take a look at the implementation, you will see that we are raising the user created domain event and passing in the user ID. This will be added to a collection of domain events on the entity base class. This collection is private, but we can access its contents using the getDomainEvents method. So let's go back to our unit test, and what I'm going to do is say user getDomainEvents, then I can call the ofTypeLink method, and I will specify the user created domain event. Then I'm going to chain a call to single or default to extract only one domain event that I'm expecting from this collection, and we're going to store this inside of a variable. So let's call this the domain event. And now I can write an assertion saying that the domain event user ID should be the user ID. The domain event could be null because I'm using single or default. However, let's run our unit tests and see if both of our tests are passing. And you can see that they are both green. So now the next thing I want to do is to slightly improve my setup around testing my domain events. So for example, you can introduce some abstractions to make writing your tests easier. So let's go ahead and create an infrastructure folder in our test project, and I'm going to add a new class inside that I will call the base test. This class will be public and abstract. It can only be inherited by my actual test classes, and I'm going to add one helper method inside that's going to be called assert domain event was published. It's going to take in a domain entity, and this is a generic method that's going to test that a domain event specified by our generic argument is present in the domain events collection. If the domain event is null by any chance, we're going to throw an exception. Otherwise, we're going to return a domain event. So I'm going to use this from my user test class, and first let's implement the base test abstract class. Then I can use my helper method and say assert domain event was published, and let's use the user created domain event as the generic argument, and I'm going to pass in the user entity. Our test assertion remains the same, and let's rerun our test to make sure that we didn't break anything. You can see that both of our tests are still passing. So let's see what else we can test in the user create method. For example, we can verify that we are correctly adding the registered role to the collection of roles on the user entity. If I go back to the user tests, here's how I would test that. I'm going to start with a fact attribute, and then let's create our test case. I'm going to call this create should add registered role to user, and then let's test our behavior. I'm going to copy the act step and the assert comment, and let's write our assertion in this test case. So I'm going to say user, and then I can select the roles collection. Then I'll say should, and I'm going to chain a call to contain, and I can pass in a role instance that I'm expecting to be inside of this collection. This is going to be the registered role, which we have defined in our domain. So if I run my unit tests again, you will see that they are all passing. Now I want to test my pricing service, and this is a domain service in the bookings folder. It contains some interesting logic around calculating the pricing details for a given apartment and the period. I'm going to create a new folder in the domain unit test project, and I'm going to call it bookings. Inside of this folder, I'm going to add a new class, which I will call pricing service tests, and this class will contain my test cases. If I go over to the pricing service for a moment, you will see that it depends on an apartment instance and a date range representing a period. So I'm first going to create a helper class that will help me obtain an instance of an apartment. So let's create that inside of the apartments folder, and I'm going to add a new class that I will call apartment data. This will be similar to the user data that I created earlier, and here's what the implementation of that will look like. I'm going to have one create method where I can specify what is the price of this apartment for one day, and I can also optionally specify the cleaning fee, and this will help me test my pricing service. So let's go back to the pricing service tests, and let's add our first test case. I'm going to be testing the calculate price method, and I'm going to say that it should return the correct total price when we execute this method. This time I'm going to have an arrange step and an act and an assert step, and let's see what I'm going to write inside of my arrange step. The first thing I'll need is a money instance that's going to represent what is the price of this apartment. Then I'm going to create a date range object that's going to represent the duration of my stay. Let's say I'm staying there from January 1st to January 10th. Then I'm going to calculate my expected total price, which is just the price amount multiplied by the length in days of my duration, and I'm going to use the currency that is already specified on my price object. Then I'm going to use my apartment data helper to create an apartment instance by calling the create method, and I can specify the price of my apartment. The pricing service is stateless, so we can create it in the arrange step, or alternatively you could create it as a static read-only field because it's not going to change between your test cases. Then in the act step, I'm going to create a variable containing my pricing details, and I'm going to call pricing service calculate price and give it the apartment and the period. And then in the assert step, I'm going to say pricing details total price should be, and I can pass in the expected total price. So this is what a unit test for a domain service would look like. So let's go ahead and run our new unit test and see if it's going to pass. And you can see that our test is passing, and we are able to verify the behavior of the pricing service. I'm going to reuse my existing test to add another test case, and this one is going to calculate the total price with the cleaning fee included. So let's add a condition to the test name, and I'm going to say when cleaning fee is included. I'm going to define the cleaning fee in my arrange step, and it's going to affect my expected total price calculation. So I'm going to add the cleaning fee amount to the expected total price. I also need to pass the cleaning fee to the call of my apartment create method to make sure that the apartment is created together with a cleaning fee. And then the act and the assert steps remain unchanged. So let's run our two unit tests, and you can see that they are both passing, and we are able to verify the behavior of the pricing service with different calculation logic. I'm going to show you one more example for the domain layer. Let's open up our domain project, and I want to show you the booking entity. It has an interesting method called reserve, which is a factory method taking in an apartment, user information, the duration of the stay, and is going to perform the pricing calculation, create a new booking, raise a domain